Hi everyone, welcome to this newly founded maths channel called Mathtastic. In today's video, I want to welcome you all by introducing the fundamentals of differentiation. The uses of differentiation are varied, but in later videos it will explain the applications of the mathematical principles of differentiation. But differentiation is basically the rate of change of a given function at a particular point. In this video, I want to introduce the fundamentals of differentiation. Suppose we had a function y equals ax to the n. If we're going to differentiate this would look something like y dash equals an x to the n take 1. So let's have a look at what we actually have done here. We've taken this exponential of the original function and we've minused 1 from it. We've also taken this exponential from the original function and multiplied it at the front of this function, as you can see here. So a derivative of a function can be represented in many ways. For example, if you had a function y equals f of x, the first derivative would be represented as y dash, or it could be represented as dy over dx, indicating the general change of the function y, which then we would go on to differentiate this function, which would be f dash x. Now that you know the very fundamentals of differentiation, let's take it a little step further. Suppose we had the function y equals f of x plus or minus g of x. If we're going to differentiate this could look something like dy over dx equals the derivative of f of x, which would be f dash x, plus or minus the derivative of g of x, which would be g dash x. This is just general mathematical notation with the dashes here, as you can see. Suppose this first example was y equals 7x to the 5, as you can see here. So, given that this rule from before, if we had y equals ax to the n, and then the first derivative was y equals an x to the n take 1, we would want to minus 1 from 5, and then multiply 5 at the start of the function. So, we would say that, therefore, the first derivative of y equals 7x to the 5 would be 7 times 5. We take the 5 down at the front of the function. And then 7 times 5, x to the 5 take 1. We take 1 from the exponential. So, therefore, the first derivative in its most simplest form would be equal to 35 x to the 4. This example is a little bit more difficult. So we have to, as you can see, we have 3 different terms in this equation. So we're going to have to kind of treat each term as an individual entity in differentiating this equation. So the first derivative function can be written as dy over dx equals 3 times 2 x to the 2 take 1. So we've just brought down the 2 times at the front of the function and took 1 away from the exponential. Now for the 2x, this term, because 2x is just the same as 2x to the 1, we go 2 times 1, x to the 1 take 1. And now for this, the 5 term, this is the same as 5x to the 0, because as we know, anything to the 0th term just equals 1, like that, if you didn't already know. So that is just written as 5 times 0, take the 0 down from the exponential, times x to the 0 take 1, but anything times 0 is just 0. So this is further simplified as 6x plus 2 and then plus 0, because nothing there, because it's times by 0. So therefore the first derivative equals 6x plus 2. But if you want to further simplify it, we can take a common factor of 2 out, which gives 2 and then times in brackets 3x plus 1. Okay, this is the third example. This one is a little bit trickier. So my advice for these types of questions, if it's a fraction over an x term, we would have to rewrite it so we can differentiate it. So this can be rewritten as 3x to the negative 2, which is just your basic indice laws. So from that, we can see that it would be, the first derivative would be equal to 3 times negative 2, take down the negative 2 times at the front of the function, times x negative 2 take 1, minus 1 from the exponential. So therefore, the first derivative will be equal to negative 6 x to the negative 3, which is further equal to negative 6 over x cubed. Now it's your turn. Pause the video here and try to solve this equation. Try to find the first derivative of this equation. If you haven't found it, or if you want to check your answer, this is how this problem will be approached. So this can be rewritten as 5x to the 1/2. So this is just rewriting the square root. So if you have a square root of x, that's the square root of x, which would equal x to the 1/2. Because in general form, if you have a root x to the b, that is rewritten as x to the b over a. We will go in further videos explaining these index laws, but for now, that's how you would do it if you don't already know. So we have this equation, so we can rewrite the derivative dy dx equals 5 times 1/2 x to the 1/2 take 1. So note that even if the indice, or the exponential, is a fraction, we still minus 1 from it no matter the case, which would be 2.5x to the negative 0.5, or in fractions we could say 5 over 2x to the negative 1/2, or further simplify it to 5 over 2x to the 1/2. Or if you want to rewrite it in terms of the square root, we can go 5 over 2 root x. Thank you guys so much for watching this very first video on this new maths channel. I hope this helped you understanding the basics of differentiation. In further videos, we'll go on to more harder differentiation equations, different types of differentiation equations, different applications of them, and so on. We'll even touch on other fundamentals of other mathematical topics, such as index laws that we briefly saw today, if you don't already know how they work. But thank you so much for watching this video. Don't forget to leave any questions below if you were stuck or need further explanation on this topic, and I can answer those questions in the Discord link below. Join the Discord link in the description for further relaxing chats, questions to be answered, or just to have a good time and hang out. Once again, guys, thank you and enjoy your day.